Hello and welcome back. Let's talk about determinants. So a determinant is a very interesting property, I guess you could call it, of matrices. You can only perform a determinant on a square matrix, and yeah, it's not used for augmented matrices either. Well, kind of, but that's when we turn it back into a regular matrix. Whatever, don't worry about that yet. So first let's talk about the determinant of a 2 by 2 matrix. So this can be written out as either DET of, we'll call it A, B, C, D, or you could also just write it as without the brackets, just like almost like absolute value bars. And so all this is going to be is A times D minus B times C. And so that's the determinant of a square matrix. So yeah, now let's talk about something called cofactors. So the cofactor is specific to a certain spot in the matrix Ij. And so this is equal to -1 to the power of I plus j times the determinant of your matrix, let's call it A, at Ij. Oh, that's JJ. Ij. Okay. So basically, if we had the matrix A, B, C, D, E, F, G, H, I, let's say our cofactor right here, well, that would be cofactor 2, 2, and this would equal -1 to the power of 2 plus 2 times the determinant at this point, 2, 2. So to find that determinant, we're going to cross this out, we're going to cross this out. So we're going to cross the row out that it's in, cross the column out that it's in. And it's going to be the determinant of what's left. So that's going to be A times I minus C times G. So yeah, this can also be done for 4x4 matrices and stuff. You're just going to have to then know how to calculate the determinant of a higher dimensional matrix, which we will talk about right now. So let's find the determinant of a 3 by 3 matrix. We'll call it A, and it's equal to 3, 2, 2, 1, 2, 1, 0, 3, 4. So we can find the determinant using any row or column, but you're going to want to pick the row or column with the most zeros in it because it will make it the easiest or shortest calculation. So I'm going to choose the third row. And so what this determinant is going to be is we're basically going to analyze this third row here. The determinant of A is going to be, well, our first one is 0 times the cofactor at 0, which is 3, 1. And then we're going to have 3 times the cofactor at 3, 2, which is where 3 is at. And then we're going to have 4 times the cofactor at 3, 3, which is where 4 is at. And so this makes things a tad simpler because this, of course, is going to be 0 because 0 times anything is 0. So what we get now is, well, this is going to be 3 times -1 to the power of, third row, second column, so 3 plus 2, times, I won't write out determinant, I'll just use these brackets. Well, let's look here. We can cross this out, we can cross this out, so we've got 3, 1, 2, 1. We've got 3, 1, 2, 1. And then we've got plus 4 times -1 to the 3 plus 3 times the determinant. Let's cross out these rows and columns that 4 is in. We've got 3, 2, 1, 2. And so this is going to be -3 times the determinant of this is 3 minus 2. 3 times 1 minus 2 times 1. Plus, this is just going to be a regular 4 because 1 to an even number is just 1. So we've got 4 times 6 minus 2. And this is, well, this would be -3. And this would be 4 times 4 is 16. So our determinant is -13. Very cool. We're not sure what this does yet, but it's how you do it. So you'll see in more videos why we need to know these things and also why cofactors are useful. So thanks for watching this video.